So let's start with a simple LAN local area network. Here we have all four PCs, PC1, PC2, PC3, PC4. What I have done is simply, just like before, I just configured their IP address, one with 10.1.1.1, 10.1.1.2, 10.1. This should be 3 and this should be 4. So okay, no issue. Let's make this 3. Okay. Make it 3 and let's make it 4. I think no confusion now. Let's put it like this. 3 and 4 pieces. Fine. Now let's make a network, classic Ethernet network. Now we don't have those thick cables and all those, but how do we make classic Ethernet network? Using a hub. A hub is a layer 1 device. It has no intelligence. So let's start with a hub. Let's start with a hub. This hub has, let's say, we'll see how many. Yeah, you can see there are 6 ports here. So 6 PCs can be connected. We have only 4 of them. That's fine. We'll connect. So connected, 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 connected. Fine. Or you can change it maybe. Let's do one thing. Let's make it a little bit easier for us. Let's say we want to connect. Okay, it will automatically connect to only FA1. Okay, FA0, no issue, no great problems. I wanted to make sure that this interface's number is the same. It doesn't matter. I think we can manage. It will be not a big problem. So let's see. This hub has no intelligence at all. It is less like a repeater. It is less like a classic Ethernet media access big thick cable where just data packets and electrical and electromagnetic signals pass through. It is like an electrical junction, nothing else. So let's see what happens when a data packet is, let's say, sent from one PC to another in a hub. So once again, nobody has any knowledge about the MAC addresses and IP addresses. So when first data will be sent, then our process will be what is called started. So anyhow, let's try simulation. Okay, let's try simulation and let's see what happens. So PC1 will do a command prompt. We'll do ping from PC1 to PC2 10.1.1.2. Let's do that. What happens? Let's see. Hey, once again, we know we have to restart this ARP process. Let's see now what happens. It reaches the hub. Fine. The hub is a brainless device, just like classic Ethernet. Whenever it receives a packet, it just floods it in all other interfaces it has. That is why a hub has a broadcast domain of one, a single broadcast domain. Whatever it receives, hub, it sends it to the entire network that it is connected to. That is why it is called a single broadcast domain. Similarly, it has a single collision domain also, we'll see. But let's proceed with what happens. See, so this let's call this PC got the ARP message. Now, if you check its ARP table, it would have created an ARP table. But let's see what happens. Let's go ahead. Now, these ARP messages had a what is called uh, source address, source IP address, and a destination IP address. And this PC saw that the destination IP address does not match. So they are rejecting these packets. But let's see what happens. This packet goes, it responds ARP. The ARP request that it got from PC1, it is responding back, and again the HUD floods it back. Again, these are discarded by these two PCs, but it is accepted by them, by this PC. So let's now see again. Same process will continue. Same process will continue because I have given the command ping, and that means 3 times generally it pings. The exact same process. It keeps flooding. The hub just keeps flooding. Whatever it receives, it keeps flooding. That is why it's called the broadcast domain of 1. Now, this process is over. Now, let's see the ARP table of PC2. It now knows that PC1 has this IP and this MAC address. Similarly, if you see the ARP table of 1, you will see that. Now let's do one thing. Let's somehow let's ping this. Okay, let's ping this from here. PC3, let it ping, but one time only. Fine. Let it go. Let it go. Similarly, let's ask PC4. Let us wait for the process to be over. Process is finished. Similarly, let's go to PC4. And let PC4 again ping PC1. Let's see what happens. Again, you see it is being flooded. Oh, finally it's done. So now, if we check what is its ARP table, it has the required details about PC1. Similarly, if you check the ARP table, it has the requisite details of PC1. Now, if you check the ARP table of PC1, it has all the information of all the PCs that are connected to this network, PC2, PC3, PC4, because all of them pinged it, or it pinged PC2 and PC3 and PC4 pinged it. So it has all the information during this ARP process. Now let's visualize what will happen if, let's say, we want to visualize collision domain. Let's see what happens when two PCs try to ping, let's say PC1, okay, at the same time. Or let's say PC2 tries to ping PC1, PC3 tries to ping PC4, but at the same time. So let's see what happens. We will do a command prompt. This is PC2. Let's say ping 10.1.1.1. It tries to ping PC1, and let's stop it here. Let's say PC3 command prompt. We'll do ping 10.1.1.1.4. Now let's see what happens. Collision. When both these species are trying to send data at the same time in a hub, there will be collision. And this collision will be detected by everybody. So in classic Ethernet and the hub, which is the same thing, we'll have CSMA CD protocols. So you see, in a hub, a collision domain is one. Whenever two packets or more than that arrive at the hub at the same time, doesn't matter which PC it is, A will collide and the collision effect will be detected by everyone. The entire network will know there is a collision. A hub has a single collision domain. So next we'll see that switches are more intelligent than hubs. We'll keep the same network and see what happens with switches. So stay tuned.